So apparently these days we have PhD level expert right in our pocket thanks to OpenAI and Claude. But here's the real question. Can these so-called PhD experts actually work in construction? Well, you're about to find out. I have a master's degree in geotech and tunneling, but honestly, I don't remember much of what I learned in college. And let's be real, you probably don't either. So naturally, I'm going to take a pretty dumb approach to solving these so-called complex problems. But I'm hoping AI will make me feel smart because that's the only thing I'm pretty sure AI is really good at. It makes you feel really smart. So here's our first problem. Let's say you are a superintendent and you want to save some real money for your company by working extra hard and optimizing the construction schedule. Now, obviously, this isn't a trivial problem. There are people who get paid six-figure salaries just to optimize schedule. And so, can AI do that? I have already written out the problem, so let me pull it up. I will just go here, and I think I have put that one in LinkedIn, and that's my scheduling problem. We have to create a multi-story commercial building project. It comes with 25 different activities, and obviously each activity has some relationships. Like you cannot live in the building until it's complete. So that kind of relationship. If you notice, there's other thing. There's normal duration days, there's normal cost, there's crash duration and crash cost. So what is crash cost? If you look at the basement wall construction, you see that the normal construction duration is 18 days, whereas construction crash duration is 12 days. Similarly, you have 28,000 for normal cost and crash cost is 40,000. What it really means is if you rush really hard and throw an extra $12,000 towards the problem, towards the construction of basement wall, you can expedite the schedule from initial 18 days to 12 days. And we have all these crash cost and normal cost for all these different activities. Another thing that you need to understand is liquidated damage. Every day we go over the construction schedule of contractual agreement of 120 days, we incur an additional $10,000 penalty. Similarly, there's an indirect cost, $5,000 per day. So what it means is number of days the schedule runs multiplied by $5,000 is your overhead charges. This is the kind of problem that we are going to solve in our first iteration. First, we need an AON diagram. That's activity on node to understand which activities are going to occur first and which come later. So we can see how everything is linked. We also need to determine the critical path. Fun fact, I had a scheduling class in my final year of undergrad, which I failed, and I had to retake it. The test, the second time you might say, was on the critical path of my career. So the critical path is the longest sequence of tasks that must be completed on time for the project to finish on schedule. If any task on this particular sequence is delayed, your whole project is going to be delayed. Tasks that are not on the critical path can be delayed a bit before they actually become critical. Now let's go and try to do some AI voodoo magic. The first way is my favorite way, where I just shut off my brain completely. I'm going to trust my AI overlords and I'm going to pray for their mercy. Let's start typing, but first I will add this problem to chat so Flowly can see it. I'm just going to go into chat. It has the problem and I'm going to write. Can you solve the attached construction scheduling problem? I want to save a lot of money and time for my company. But do we need the balanced version? We are talking to AI overload. So I'm just going to go full throttle and turn on the max mode, which actually means I'm just going to use the most costly model that I have. Very simple. Let's run it. Let's burn some money and see what happens. Okay, so my AI overload is spinning and it's reading the problem and it's going to present a solution to me. I already see that AI has created some plan to solve the problem. So I'll go let it run. And meanwhile, I'm going to tackle the problem the second way, which is going to be a bit more hands-on. So while AI is solving this problem, I'm going to spin a new chat and I am going to write the second way of solving the problem. First, let me attach the problem. So what I want AI to do is create multiple workers and each worker will present different solution to me and I will be the judge of what solution is the best solution for me. So here we go. Please, and this time I'm going to keep the language a little bit simpler, more sophisticated. Let's see. Please see the attached problem. Please use multiple agents to test different solutions, then present the most optimized solutions solutions. So this time, because we are running multiple different models, I'm just going to do a little bit dumber version of the model and start the process again, and hopefully we'll let the AI solve the problem. Okay, here we go, spinning the wheel. Now I can see the AI is already thinking, trying to solve the problem and all, but there's a third way, which is completely hands-on. I want to understand the problem in the nuance and the depth, and I want to go step by step in solving that problem. And that's what we are going to do in the third version, where we'll take the problem, we'll split it into different chunks, and then we are going to solve with the help of AI, of course, but it will be a little bit more nuanced. Version 3. In here, I'm going to go to Drive and just going to attach my problem again so AI can have it. And then I'm going to go step by step. The goal is for me to understand how to solve this problem, at the same time helping AI to solve the problem too. Can you help me understand the problem? Sorry, help the problem. How can I solve it? What are the different approaches? Actually, I'm going to say not how can I solve it, but how can we solve it. Okay, I'm also going to just name this as third. That way I can remember which one was which. First one, second one, third one. Oh, I think the first portion is complete. Let's read through it. Oh wow, that's a big one. Problem, there are 25 activities, 20 workers, 2 crane, 1 excavator. Understood. I need to do forward pass, backward pass, total critical float, key formulas for all the process backup. So this is very manually. I can see how I can solve this manually. Resource constraint, the challenge, the scheduling may be feasible time wise, but infeasible resource wise. You must level resources without exceeding 20 workers, 2 crane, and 1 excavator. The goal, the final optimum, that we want to minimize liquidated damage, indirect cost, direct cost. Key concept, cost law. This tells you the cost per day saved when crashing an activity. So there's another part of the problem, which is the delay analysis. Let's say we had unforeseen soil condition, which happens all the time in construction, and we hit 3 days delay. So now we need to understand the impact on the whole project, and we have to do delay analysis for that one. Okay, solution, manual, draw network by hand, use tables for calculation, best for learning or exam. Spreadsheet approach, build Excel models with formulas, use conditional formatting for critical path, good for medium complexities. And then professional software, Python with network X for graph analysis, custom algorithms for resource leveling, full control over calculation. So I want the first approach. I solve using free software, and this is where I just wanted to show you like how the system, the AI, can use the free softwares to run these algorithms and everything. So we're gonna give it a rest. We're gonna come and see how the solution is gonna look like. So we can evaluate the AI agents correctly. I need a scoreboard, and maybe I should ask AI to create a scoreboard first. And let's try some open source model for it. And let's see what AI creates a scoreboard that we can fill out and evaluate all the 3 different agents. Okay, so we got our scoreboard here, and it has everything that I wanted: quality, thoroughness, correctness, and we have all the 3 agents. So let me open it up and check it out. Okay, this looks nice. So we can use this thing to mark and score our agents. I'm just going to go to the first one and we will see how that looks. So the critical path, this looks good, I think. And we also have 277 days, which is the right answer. So it did the right answer. And then delay claim recovery is 90 days. So yep, sorry, 18 days. So that all look good. So the answer is correct. And so it gave us the final um, report, which is really thorough. It covers critical path, duration, workers, activity delayed, key impact, cost, time analysis, crash detail summary. So I think it covered all the bases really well. And so we can give it a really high mark on this exercise. We also got some nice diagrams, histograms, resource histogram, nice. We also got some Gantt charts, okay, and then we have got CSVs for all the different activities. So let me go to the second one now. And second one was the one that we asked it to create multiple agents and then choose the right answers among them, or the best one that it thought solved the problem. So this one, I think the schedule again for the second one, I think 15 activities. So it created the critical path is correct. The other thing was we cannot do the job in 120 days. We need 277 days. So it calculated those correctly. And we have 18 days of extension entitled. So I think all these parameters are same. And so I think these two are similar so far. The report looks, so it created a AON diagram in the report itself, and it has the reports cover thorough aspects of everything. It did the analysis, time entailment, delay, claim summary. What I see here is it says that 8 days are excusable and 10 days are compensable, which is not the same thing that the first AI agent said. It said that out of the 23 days, 18 days were our own. And here it says that we can only charge for additional 10 days. So this is something, the discrepancy between these two. Compensation is where I think we need to go into the depth. For thoroughness, it did a really good job, but for presentation of the data, it used a simple text document, and it even created the diagram in the text document. So on presentation wise, I will rank this lower than the first one, which gave us really nice looking graphs. I haven't checked how correct those are, but it did a good job at presenting the data. So now let's go back to the third analysis and see how it fared in terms of the presentation against the other two. So it has a complete report, which is good. The formatting of the report doesn't look great, first few things, but it has the complete report, and other things look great. It has covered all the bases. So the report is comparable with the other two agents. It also created an Excel file, which is interesting, where it has all the summary, all the tables. So the first agent, if I remember correctly, it created multiple different CSV files to present this data. But the third one, where we interacted a little bit, it created an Excel sheet to give us all the data in one file. So this is a better presentation than the first one for me, because I don't want to open multiple file. I would look everything in one simple Excel file. And it also gave us all these diagrams that the first agent gave. So I think the presentation and thoroughness, agent first and agent 3 are the best one. So it has Gantt chart, nice, and we have diagram, nice, we have resource, nice, and we have okay. So all these things are, it covered everything really nicely. So all good. So now here's our scorecard, and let's fill it up. Fully autonomous quality, I think I will give it 4, because in the delay claim analysis, it didn't go into the depth as much the other two agent went, but it covered all the bases very correctly. So 4 out of 5 5 out of 5, and here also I say 5 out of 5. Thoroughness, yes, it went through really nice. It completed all the depth and cover, so 5 out of 5, 5 out of 5, 5 out of 5. Interactivity, let me think. So the first one, it gave us CSVs plus graphs and some images to look at. So it was good, but it lacked certain qualities. So I'm gonna give it 4. And then the multi-agent one, it just gave us a one text document, so not so great. And then collaborative one, it gave Excel file and all the graphs. So I'm just gonna give it 5 out of 5, right? So correctness, I think I will just give it 4. I think all three agents covered all the bases. There's some discrepancy between how much actual money we are entitled to when it comes to delay claim. The all three agents got the 18 days correct consistently. So the question is why the two agents said 50,000 versus the first one said 90,000. So I can dig deeper into that one. So the first one got 4 4 5 4. So 12 plus 5, that's 17. And then this one got 5 5 and 3, 13 plus 4. Interesting, 17. And then you got 5 5 5, 15 plus 4, 19. So this is interesting. The other two where we had the agents run autonomously gave us comparatively inferior result than one where we interacted a bit. So I was really curious why there was a difference between 90,000 and 50,000 for the analysis of the first agent and the other two. And so I asked one of the agent why there was a difference. And the answer was the other two agent didn't think that we should get compensated for unforeseen soil condition. It says both parties control unforeseen soil condition and it should only get time extension. So this is one of the great example where when you are doing an objective exercise and there are elements of the subjective understanding, and if you rely on the agent's subjective understanding, that's going to change based on model to model and from one chat to another, because the subjective, these models are really probable in nature. So sometimes they could see that this unforeseen conditions are responsibilities of a contractor, but sometimes they might see that this is the responsibility of the owner itself. So you, when you do these kind of exercises, you should be really careful about the subjective elements of these exercises. Now it depends what your contract says here. As a general contractor, I would say that the owner is liable for this kind of thing, and I should get paid fairly, because my troops, my people, my laborers, my team is on the ground during that time. Any errors made during GDR or GBR development, that shouldn't be my problem unless I have done it and the contract says it explicitly. I'm glad that these agents had some little bit of inconsistencies, so we could demonstrate this point really well. I think AI agents can do these problems really well. And next time we should deep a little bit deeper into problems that have 200 different activities or 300 different activities